In today's video, I'm going to share the data structures and algorithms roadmap that helped me to clear interviews at Amazon, Google, Hopper, and many other top tech companies. Mastering these concepts was not definitely an easy journey, especially without the right preparation approach. So I will walk you through the strategy that worked for me, and hopefully it will help some of you as well. So before we actually diving into the roadmap, let's understand the difference between data structures and algorithms. So think of data structures as the way we organize and store data, like arranging tools in a toolbox. They help us efficiently access and modify the data. Algorithms, on the other hand, are like step-by-step instructions that you follow to use these tools to complete a task. While data structures deal with what, algorithms focus on how. Let's take a real-life example to understand the importance of DSA. Imagine you are booking a flight. The flight schedule, passengers list, and the routes are the data, and they need to be organized efficiently. For instance, an airline's reservation system might use a hash table to quickly look up the passenger details by their reservation code. Here, the data structure, like hash table, allows for quick data retrieval. Now, to find the shortest route from your city to the destination, we might use Dijistra's algorithm, which operates on a graph data structure representing airports and the flight paths. The graph stores the data, nothing but airports and connections, while the algorithms finds the shortest path. This example illustrates how DSA work hand in hand to solve real world problems. Now let's see, what are the essential data structures that you should know. Arrays, this is nothing but the collection of elements identified by index. Linked lists, these are nodes connected in sequence with each node containing data and a reference to the next node. Next comes the stack. So it follows the LIFO, nothing but the last in first out principle. Queues follows FIFO, first in first out principle. Hash tables, it maps keys to values for the efficient lookup. Trees, it represents hierarchical structure with a root node and child nodes. And finally, graphs, nodes connected by edges representing networks. Now here are some of the key algorithms. First one is the searching algorithms, where it involves linear search and binary search. Sorting algorithms, which involves quick sort, merge sort, bubble sort, etc. Tree traversal algorithms involves in order, pre-order, post-order, and level order, etc. Graph algorithms like BFS, DFS, Dijistra's algorithm, etc. So what to learn first? When starting the DSA, it's crucial to follow a structured roadmap. Begin with arrays, as they are the simplest and foundational. Then move on to linked list, understanding their different types. Something like single linked list, double linked list, and circular linked list. Next, learn about stacks and queues, as they help in understanding basic operations like push, pop, enqueue, and dequeue. Hashing is another important concept, particularly for efficient data retrieval. Once you are comfortable with these, then dive into more complex structures like binary trees and graphs. Make sure you are very thorough in searching and sorting algorithms for each of these data structures. I would recommend practicing medium complexity questions on platforms like LeetCode, focusing on these data structures to solidify your understanding. How to learn, or the importance of learning patterns. An essential aspect of mastering DSA is recognizing and learning pattern solving problems. Coding patterns have been the greatest game changer for me when it comes to interviews. Patterns simplify the learning process by reducing the number of unique problems that you need to solve. For example, 2 pointers useful in problems involving arrays or linked lists where you need to find pairs. Sliding window is ideal for problems involving contiguous subarrays. Top K elements focuses on finding the largest or the smallest K elements in a dataset. Recursion involves a function calling itself to solve smaller instances of the same. It's a common technique used in algorithms that operate on recursive data structures like trees and the problems like Fibonacci series. Modified binary search helps in efficiently finding elements in sorted structures. Divide and conquer pattern breaks a problem into smaller subproblems, solves each subproblem independently, and then combines their solution to solve the original problem. It's commonly used in algorithms like merge sort, quick sort, and binary search. Backtracking is used for problems involving in permutations and combinations. Dynamic programming, on the other side, is a key for solving optimization problems by breaking them down into smaller subproblems and then storing the results to avoid redundant calculations. Understanding these patterns allow you to tackle a wide range of problems by applying a familiar approach. I highly recommend you watching this video before jumping into solving LeetCode problems. Here are some of the problems grouped by patterns. You can also find the link in the description. How to practice. Finally, one best way to solidify your knowledge and get interview ready is by taking mock interviews. They help you practice under pressure and identify areas where you need improvement. So use platforms like Tramp, interviewing.io, or simply pair up with a friend. Make sure to talk about your approach, space and time complexity, unit tests, edge cases during the interview. Remember, the goal is not solving hundreds of questions, but to understand the underlying principles so that you can tackle any sort of problem. So start with basics, move to advanced topics, learn key patterns, and keep testing yourself with mock interviews. To wrap up, mastering DSA is all about following a structured learning path, understanding underlying concepts, and practicing consistently. All the very best.